My screen is visible, right?
I can see Zoom.
Okay. So today we can cover Kubernetes taint and toleration. Okay. You heard about that, right? Or both of you? Any idea? Taint and toleration.
No.
First time. Okay. We can start the theory, then we can do the same on lab, so you will get more idea, like how these taint and toleration works on Kubernetes. Okay. Kubernetes. We called as taint and tolerance. Taint toleration. So, coming to the scenario, okay. So when we deploy application, okay, how we will deploy application to Kubernetes? How to deploy application? The step-by-step process.
YAML files will be deployed, applied, or applied.
Right. So here we have the Kubernetes cluster, right? We have a cluster here. Master part and worker part, right? And we have a couple of node here, node 1 and node 2. Okay, this is a high level overview whenever we set up a cluster. There's no pod because we don't apply anything. Some pods are there. That's for running some master part components or some cube system components like etcd. Some are there, okay, under the namespace cube system or cube proxy like that. Coming to the application pod, we need to deploy it from scratch, right? So we need to write the YAML file. Then we have to apply using kubectl apply command. This is from local, okay, console like that. This is from local machine. And kubectl apply file name. Then it will push that file to the API, right? This will authenticate with the API server. And it will go through the like scheduler, I mean controller, scheduler. Finally, scheduler will schedule the application pod. Okay, here for example, the replica is equal to 3. That means the schedule will schedule the pod to the healthy node. Okay, that's the final stage. I mean, for deploy the application to corresponding node. So the 3 replica, right? So the scheduler, okay, scheduling our pod to corresponding node. So pod 1, pod 2, and pod 3, like look like this. So this is the scenario, right? All of you.
Yes.
Okay. Now we need to learn what is pain and toleration. In this scenario, okay, in this scenario, this is a random scenario, consider like that random scenario. And the application, whenever we are applying that kubectl command, the application or the application board will create on corresponding node. So this is our node 1, and this is our node 2. So some other requirement, okay, there's a requirement. Like machine learning. Okay, we have a high, we have to deploy some complex application that is related to machine learning or AI. Okay, so that specific application need not GPU, sorry, not CPU, it's need GPU. GPU. This is one of the scenario, consider like that. And we need to ensure that our, for example, in this Kubernetes cluster, we have 2 nodes, okay? So the node 1 have GPU, consider like that. Node 1 have GPU power. Okay. So the requirement, okay, coming to the point, we need to talk with the Kubernetes, okay? We asking or yeah, we asking to Kubernetes no schedule to the corresponding node, okay? That means we are asking to Kubernetes uh, no first we need to the requirement is only the assigning label, okay? Whenever we're deploying some application, coming to the Kubernetes YAML file. Okay, in previous YAML file, we didn't define anything related to taint and tolerance. But coming to taint and tolerance, we taint the node. Okay, why we taint the node? That means there is no schedule for the specific node unless we define the toleration. Got it? That means Kubernetes not deploy any pod, any random pod to the specific node unless we define that toleration for that. Because in this case, okay, this specific node have GPU, so we can assign only the pod that needs to run on the specific node. Got it? So how to do that? First, we need to taint the node. Tainting. If we taint the node as no schedule, okay, taint the node as no schedule, no pod will run on here. Whenever, for example, we have a couple of YAML files, so we apply. So the Kubernetes know this is taint one, so its condition is not schedule. Okay, so the scheduler not taking the specific node, it will applying the application to other node. Got it? Otherwise, we need to define toleration. Where we need to define the toleration? On the YAML file. So coming to the YAML file of the deployment, okay, there is one syntax we need to add toleration, and we need to define the label as well. Whenever we tainting a node, we need to define the key and value. So the same key and value we need to define whenever we define the specific application YAML, okay, or the specific application toleration. Coming to the toleration part, we need to define the key and value. So what will happen whenever we applying that specific YAML file having toleration goes to this the taint node. Got it.
Oh, got it. If that node is tainted, the scheduler won't schedule and we can't able to deploy anything
Right.
on that particular node. But we
Unless
want, if we want to particularly deploy something on that node, we need to add a tolerance of whatever the deployed, like tainted key value pair in the YAML file, so that that particular application will be deployed only to that node.
right.
Okay.
Got the point, right? All of you.
I'm good.
Okay. So in this scenario, okay, the taint and toleration scenario, some issues are there. Okay. For example, we have the cluster and we taint a node. Consider like that. This is a node 1 and this is our node 2. Okay. So consider like that we taint this one. We tainted, okay. Node 1 we tainted, node 1. And the normal scenario we taint, how we tainting using a simple command, okay? Like the command is, I think, kubectl taint, the node, sorry, node, then the node name, then the key value we need to define, key value, value, then no schedule. So this is a command, okay? This is a single command that we use to taint a node. So the given this command we need to apply from the local machine, right? So this is a kubectl command, and we can apply this one from the local machine as well. So first we need to gather the information of the node name, okay? The node name. How we will find the node name on Kubernetes?
kubectl get node.
Yes, kubectl get node symbol. So whenever we type in kubectl node, we can see. I mean, Kubernetes will list the node details. So we need to take that corresponding which node that we are going to taint, okay? In real world scenario, one of the example, right? Some node have some GPU power, so we need to taint that node. So similar scenario, we can tainting node, okay? Or some higher configuration nodes are there, so we need to taint that one. So the Kubernetes will exclude that one, okay? Whenever applying application. So kubectl get node will getting, I mean, showing that node details. So we need to take that node name and put it here under the node name. So the corresponding node will be tainted as node schedule. Finally, we define node schedule, okay, on the command. So this is a way. And whenever we writing the application YAML file, we added the toleration part. Toleration. Coming to the toleration, we need to define the key, which key that we define here. Okay, this key actually we need to define here. For example, like production or like any environment we can define here. Okay, then we need to define the value. Same thing, value. These all things comes under the YAML. Okay, for the corresponding application. So above we can see the API version, tag kind is deployment, everything is we can see above the image, and we need to define the value as well. So these are the things that we added on the YAML file, and we apply this corresponding file. Okay, this specific YAML file. This application will deploy to the tainted node, right? Tainted one. For example, the main thing is okay. The replica here is consider like that 3. Okay, replica. We define the replicas as 3, and we apply the YAML. So the thing is here by default, 3 is the replica, right? So by default, the application goes to the tainted node, okay? But the problem is, so for example, this is one of the replica, I mean the pod one. That is deployed on the tainted one. But the problem is Kubernetes will deploy the other pod on, okay, other node as well. So that's the problem. So the pod 2 goes to untainted node, similar like that. But our application will run, one of the pod will run on the specific tainted node. But the problem is some pod will deploy to other node as well in this scenario. Got it. So here actually the other things came like node affinity. Node affinity, one more thing there, anti-node affinity. Anyone hear about?
No idea.
Okay. Uh, Node affinity, leave the node affinity and anti-node affinity. Okay. Coming to the lab, I will show you how we leveraging node affinity and anti-node affinity similar to this scenario. Okay. I mean, this scenario means in this case, you can see whenever we are applying that application, the the application YAML have the toleration. So whenever we apply, application goes to the tainted one, but some other instance of the same application goes to untainted node as well. So in that case, actually, we need to thoroughly define, okay, that application, okay, the toleration application or the toleration port only goes to tainted node, okay. So that's we define using node affinity and anti-node affinity actually. So for that, it's a simple thing. We only added the specific node affinity parameter on our YAML file. I mean this file. The application we define the toleration, right? On below of the toleration, we will define node affinity. Okay. Node affinity is like it will control. Okay. Node affinity we using node affinity to control the same. Which node that our application will run. So we need to define using node affinity. So above scenario, similar thing that we did, right, using tainted and toleration. But the problem here is some pod or some instance of the application goes to another node, untainted node as well. So that's why we forcefully, okay, forcefully running all the pod on the tainted one. Got it, all of you. So coming to the lab, okay, you will get more idea if you have any confusion. Any doubt?
So that is the only problem when there is a replica defined in a YAML file is gonna like even when we have like said that we have like tolerance defined in the YAML too, but it's gonna deploy the replicas on other nodes. So in order to avoid that, we need to add node affinity in our YAML file. So that is the only disadvantage, or do we have anything else too?
Some others, you mean the other scenarios, right?
That's what you said, right? They might we have a few like few stuff which we cannot implement through this. So we have added node affinity. Is there anything else other than node affinity?
Yeah, these are things actually. For example, some other case for mm, logging scenarios. Okay, for example, we have some logging application. So we need to ensure that the specific service running on a specific node. In that case, we can use taint and toleration, similar like the GPU case. Okay, then logging GPU. These are the common scenarios actually. The common scenario is whenever in my environment we using logging systems. Okay, the
Hmm?
ELK stack was similar like that. So we define the similar things on a specific node. Okay, otherwise it's mixed up with the application and everything. For example, mm, there is a ELK stack there. Okay, EL. So we need to deploy the ELK stack on the Kubernetes cluster. So what we need to do, we separate, I mean, create a specific node for the ELK, node 3, and this is stated. Only deploy that ELK stack on this one, like Kibana, Logstash, Elasticsearch, or Fluentd, similar thing running on the specific node as well. So on other node, we can see the applications only, app one, app two, like that. So it's not, I mean, some lot of applications for so ports are for the ELK, right? I think around 13 something ports are there for the ELK stack. And that is not affecting our application, or it's not mixed up with application container, application pod as well. So you can easily manage as well for like similar things. Okay. So ELK we using for the centralized logging system, right? Centralized logging system. We go through the part, right? ELK. I
Mm,
think, yeah,
think
ELK or EFK, right? There is a theory part we covered, right? On the centralized logging system, I believe.
heard of this, but
I
centralized
mean,
logging system, but
Kubernetes, Kibana, then Logstash, I think. These are the three different services to getting that, I mean, logging from our entire cluster and sending to the another service like Logstash. Finally, it will display everything using Kibana dashboard. These are the open source tools like to set up a centralized logging system. Okay. For the monitoring system, we use Prometheus Grafana, right?
Grafana,
I
yeah.
clear. I mean, uh, yes, I
Even
wrote. Right?
Prometheus and Grafana is, yeah, you covered. I'm not sure about this one though.
Okay. I
Is there a
think I
lab
covered.
associated with this one? Centralized
No,
diagnosis? No,
no,
just only
no.
the theory part?
Theory, I think theory is covered. I think so. Like for
That's fine.
example, we
Let's
have.
go with the lab today, that taint intolerance, and maybe we can cover this.
Oh, okay, okay, okay. So we can jump into the lab, right?
Mhm.
So we can quickly set up the Kubernetes cluster. Quickly deploying one Kubernetes. Okay.
You are not showing the screen actually.
Oh, sorry. Which screen? Give me a second. Yep.
AWS,
So
AWS. Taufik, in your like in your workstation, are you gonna use like Visual Studio Code or something else? What else you guys are using?
you should have code.
VS Code, right? Okay.
For the local things, I mean, set up the Visual Studio Code. So that specific application have a lot of extensions. Like, give me a second. I will show you.
So for pushing into the production, how do you do?
Means
Like promoting to production, like for local deployment and testing, you're gonna do make use of your local system, but when pushing it to production,
hmm.
are you gonna go with the Visual Studio Code connecting your what we call AWS through it, and you're gonna
For
push it?
client project or for client project, they gave the remote PC, right?
Okay,
So we log into the remote PC first from our machine. Then on that PC we can see uh, like that Visual Studio and everything. All the application or even the machine or the cloud PC, we can call it as a cloud PC, okay? Because you familiar with
so
that thing, right?
yeah, I know how it works with the remote stuff. We have all the applications when we're gonna work there and we're gonna push it. So you're not
Yeah,
going
that
local development
yes.
only. You're using your laptop rather for the production. They have a different remote systems wherein you log into
No,
there and
not
you.
production. For example, in like we have a client. Okay, client is based on UK or US. Okay, so we have to work. We need to work for the client, right? So whenever they onboard us, okay, like a full employee or a contract based employee, they will give the PC
Of course, yeah, they're
because this
gonna.
is a virtual support, right? So
Mhm.
um, my company, okay, my company's client is that UK, okay. So my company gave me a physical laptop, right, for working.
Mhm.
This is a physical laptop. So first we need to log into the physical laptop. Then we need to work on the client project, right? So we need to, there's a URL there. So like Office 365, similar like that. So go to the URL, then open. I mean, we can see in console, we can see the remote PC as well. So RDP to the corresponding machine from the,
RDP. Okay.
so we logging on the client machine.
Okay.
Client machine is their network actually. This
Oh,
is
okay.
client network. So we can, I mean, if you have the permission, we can do the work from the PC, like open Visual Studio Code on the PC, inside the PC. So we can work like that.
Okay.
So coming to production, right? I didn't get that point actually. Deploying application to production, right? Or using
Yes. Yes.
CI/CD,
Yes.
CI/CD.
Promoting your code changes to your production.
Okay. Protein. I will
Just
show
like
you.
CI/CD, yeah, pipeline, CI/CD pipeline.
So there is a
For
development
the
team.
okay,
So we have the repository here, repo. So you consider like we have a pipeline, okay, a pipeline, and this is our production environment like Kubernetes. Okay, currently at the same application running. So whenever the development team pushing any new code changes, what will happen? That pipeline, I mean CI/CD server will take that new change and build it again. That's the process, right? So
okay.
coming to production environment, we have to do something like if any of the development will push anything, okay, that thing, I mean the latest one build, okay, the CI will happen, but the CD part, okay, CD, we have to set up some like approval stage or similar like that we can do, okay. So
Okay.
the same application here, the app code, right, source code. And this is our production, right? So
Mhm.
before deploy application to production, we can set up the dev as well here. Dev, UAT, got it.
Okay.
Okay. Coming to dev. We can point it to dev. Then UAT. Yeah. then production. So here we can see we can set up any of the infrastructure, okay, like Docker or Kubernetes as well on each one. Okay, for example, some most cases, in our case, we have two environments. One is pre-prod and production. We mostly using what Kubernetes. But in this scenario, we can use virtual machine or anything as per the requirement. Like for development, we have a virtual machine, UAT virtual machine, and here we have a Kubernetes like that. Or else we can use Docker, Kubernetes. So the pipeline, okay, whenever the development team push anything, okay, so the pipeline will start and that new changes deploy to dev. That's fine. Then the second thing, if the development, the deployment goes to development succeed, then it will deploy to UAT. Only succeed, okay? We can add the parameter. If it fail, then the pipeline will fail. That's all.
Okay.
Then UAT completed. Okay, UAT completed, then we need to successfully deploy to production, right? But before deploying to production, we have to set up some approval things, okay, because it's production, right? The approval means the pipeline will break here, okay, and send a mail to the. We need to configure everything, okay, the approval thing.
Okay.
Send a mail to the application team or application managers.
Okay.
So what will happen? The pipeline will stop the process to deploy to production, and UAT and dev fine, okay, but it's not deployed to production because we set up the trigger things. This is a standard practice actually when coming to production pipeline.
Maybe for
So
production, you manually do the production deployments.
not manually, it will automatically deploy, but needs that approval from the application manager. Some cases we have to add production release team, high level stakeholders, okay.
Okay.
Production release team. This is a DL actually. Some lot of members are there.
Okay.
For
Okay.
example,
Okay.
application manager, two things of production team. Any of one
Any
will
of them
approve.
can
That's
approve it, right? Okay.
right, right.
Whether the approval
Also,
will be in the form of email or how does it gonna work?
email. It will
Email.
trigger the email, and whenever they click the email, they will landing to the corresponding CACD part, CACD window. Like if it
Okay.
is a Jenkins, they can see the Jenkins dashboard, and there is a approve or rejects
Okay.
things they can see. If they
Okay.
approve, this will continue.
Okay.
Also, we can add a sequential approval. Sequential. For example, first it goes to the application team. If they approve, then after it will go to the next team. Got it. So
Okay.
both team approval we needed to deploy the application to production. So
Got it.
first, using sequential, we can add the application team first, and if they approve, then go to the production team. It will trigger another mail to the production team, and the member will approve. Then it's fine. This will continue to deploy to production.
Okay. Maybe it is different for different companies. In our company, what we will deploy it to this one development. Then it will be going on to the sandbox testing one. Then if everything goes well, even we have to like it is a automated process. What we have to do, we have a Slack wherein I integrated the Slack with um, code build, so that if I give a simple message, deploy this version to prod, it will directly start deploying to prod. Then if it is succeeded, it's gonna give back. Only few members like me and my manager has the privilege to do that. So
No.
we both used to do it actually. And at the end of the day, if it is succeeded, it's gonna send back to a different channel in the Slack saying that succeeded, and it is deployed by my name or my manager name. If it is
Hmm.
failed, it's gonna get back with the like a message, it is failed due to this.
Okay, got it,
So
got it.
it is like that. So I'm just like curious to know how
Yeah,
it
it's
works
coming
with you.
to the organization perspective will change. I mean,
Yeah.
we need to set up as per the requirement.
Okay, I think
Yeah,
it's done.
here,
Hmm.
yes, Kubernetes cluster is up and running. So you can start the taint and toleration. Okay. So first, uh, we need to taint one of the pod. Okay. Sorry, node kubectl.
What?
Sorry.
Get node. Yeah.
So we have three node here. So there is a requirement. We have to deploy some application only to a specific node, like the pod. This is a name, right? The
Mm-hmm.
pod name. The IP, okay, the local IP that ending with 17.6. So we need to set up this specific node. Okay, we need to, exclude this node, okay, for the regular application deployment using taint. So the command kubectl, we are going to taint, okay, kubectl, taint node, T-A-I-N-D, taint nodes. Then the node name we will define. Here we can copy one of the node. Okay, that's fine. Then we need to define the key value. Like for the key, we can set the environment. Okay, consider like that, the environment. ENV. This is the key. This key actually we define in the where application YAML first manifest production and define no N capital S capital. Okay, schedule. Yes, so this is fine. This is a way we taint. Yeah, tainted. So we say don't schedule any pod here. Got it. Any pod means any pod on the node that ending with this name. Unless it tolerates this taint value env production. Got it.
Yeah.
We'll check some sample application. So we can deploy the application first without a toleration and with the toleration. I will show the entire application deployment to you all, right? Different tiers of application.
No,
I
you
think
didn't cover that one.
okay. So I'm going to deploy a sample application, okay, as a demo purpose. With and without toleration. Okay. So this is the toleration demo, but in this case, we are not uh, define the toleration. Okay. We can yeah, this is demo. I will deploy one another application. So this is a way we define the toleration. See, under the toleration, we need to define the key. What key that defined whenever we taint a node, the key is env, the environment, right? And operator equal value. The value key value is production. I mean, uh, key that's a format. Okay, key value then the effect. In our case, whenever we tainting a node, we define the key as env and the value as production. Okay, anything we can define. Okay, under the key and value, and the effect is node schedule. So the specific node will take any. I mean, by default, it won't take any application. Okay, the scheduler not schedule any application on the specific node unless that application have the toleration. Save and exit. Some sample application we need. So before we need to run out that application and see that specific port is deploying to the taint one or not. Visual Studio Code. We'll go some sample application. Okay, we'll go with this one. That's fine. So I will clone this.
Capital.
Super module. Okay. So I'm going to apply the deployment YAML file. Okay. CTL apply. So two pod is deployed. Okay. And port 0. Wait. See, the two port only deployed to it. Our taint one is 17, right? This one.
Yes.
So no pod will deploy. This in this case only two replicas is two, right? So I will add more replica. No, because three ports are there. I'm making this one to 9. Play it again. See, any of the port will goes to our taint one. They're ending with the 6. All the ports on the node path, okay? 255 and 254. See, for the only that application goes to these two node only, and this one currently tainted. Got it. So we explored, right? Using
So
taint.
you said it's gonna go on the okay. If it is tolerance, it's gonna
No, yeah. In this case,
okay.
we didn't tolerate anything. This
Okay.
is by
Okay.
default. Now we are going to apply the tolerance application YAML. See this CD plus. So this is a tainted one. P YAML. Cat P. See.
It's demo
Yes.
data.
Yes. So this is a tainted one. Sorry, this one have the toleration. This part. Otherwise, for the previous application, if we need to add this part, all application goes to the tainted one. So now we are going to add kubectl get node. Okay, now I'm going to add or apply the demo. Again, I'm checking. Okay, see, got it.
Okay.
So this is the way we deploying a specific node using taint and toleration. So in this case, only one replica. If we have more replica, then I will show you, okay, how this, I mean, the rest of the application instance goes to the another node as well. So tomorrow we can continue, right? Using node affinity and anti-node affinity. So we can
Yeah.
conclude this part. Time
Okay.
is up there. Yeah. Then any doubt?
I'm good.
Okay. Then we can wind up, right?
Yes.
We'll connect tomorrow and complete that, including node affinity and anti-node affinity. I will add some more more replica on the same, okay, and apply. Then you can see some code will on other node as well. So that we need to clear using anti-node affinity. Sorry, node affinity and anti-node.
Tomorrow you're gonna cover anti-node and node affinity, right?
Yeah,
Is there anything
node
else
affinity.
you're gonna like cover tomorrow? Because I think it's gonna be simple.
Mm, not simple actually, but anti-node affinity we need to add more arguments on the YAML manifest.
Okay.
Okay, I will add some pending topics on Kubernetes as well. Okay, if you have time.
Okay. Sounds good.
Okay, yeah. Then we can wind up, right? All of you.
I'm good.
Then bye, bye all.
Yeah. Bye.